In just 48 hours, more than 3,800 earthquakes, each measuring 5.3 on the Richter scale, rocked the new crater area. Magma movement was observed to have increased dramatically, and Steamboat Geyser erupted with incredible intensity. Behind its majestic landscape of geysers and mesmerizing geothermal valleys, Yellowstone National Park harbors one of the greatest geological threats on Earth, an active supervolcano located beneath the park. With a massive magma chamber extending tens of kilometers beneath the surface, Yellowstone has been the object of intense scrutiny by scientists around the world. For years, Yellowstone has exhibited signs of mild to moderate volcanic activity, such as small earthquakes, gas emissions, and periodic geyser eruptions. However, in the world of volcanology, a combination of small symptoms can turn into a major warning. When several indicators appear simultaneously and on an unusual scale, the scientific world knows Yellowstone is not playing around. In the past 2 days, Yellowstone has once again been at the center of scientific and public attention. On a beautiful morning, as sunlight began to penetrate the thin mist above the hot springs, a group of scientists were conducting routine observations in the new crater area. However, instead of finding stable conditions, they received surprising news that left geologists uneasy. More than 3,800 earthquakes were recorded, shaking the new crater area, with the highest magnitude reaching 5.3, a significant number for a volcanic earthquake swarm. This intense seismic activity often indicates the movement of magma or hot fluids beneath the surface. The massive earthquake not only shook the new crater area, but also spread to several geyser areas that had been naturally rumbling. One area affected was the Norris Geyser Basin, known for its high hydrothermal activity. The powerful tremors caused several geysers to exhibit unusually increased activity, with more intense and unpredictable eruptions of hot water and steam. This sudden and massive activity immediately sparked concern among scientists and the wider public. Yellowstone is known not only as a beautiful national park, but also as the site of one of the world's most dangerous supervolcanoes. According to reports from the Yellowstone Volcano Observatory, YVO, these earthquakes occur in a dense, repetitive pattern, a hallmark of increased internal pressure. Several monitoring instruments also recorded rising temperatures at the ground surface, as well as increased release of volcanic gases such as carbon dioxide and sulfur dioxide. Changes like this should not be underestimated, said Dr. Marcus Litton, a senior volcanologist at the University of Utah. While Yellowstone frequently experiences swarms, the number and strength of these eruptions are significantly higher than average. We are continuing to analyze the data to determine if this is part of a natural cycle or a sign of something larger happening beneath the surface. But a surprising moment occurred. Magma movement was observed to increase dramatically, causing 7 centimeters of ground deformation in less than 48 hours. Satellite and GPS sensors on the surface indicated pressure from a shallow rising magma chamber. New data from INSAR, Interferometric Synthetic Aperture Radar satellite imagery, shows an elliptical pattern of ground uplift around the new crater area, similar to patterns seen in pre-eruption events at other volcanoes around the world. The magma chamber is estimated to be at a depth of less than 5 kilometers, much shallower than Yellowstone's normal activity, which typically lies at depths of 8–10 kilometers. The rise of the magma chamber to shallower depths increases the risk of a phreatic eruption or even a small magmatic eruption, said Dr. Helena Cruz, a geophysicist with the USGS. This is one of the most active periods we've observed since modern monitoring began, said Dr. Ellen Navarro, a geophysicist with YVO. We're seeing a combination of seismic activity, elevated ground temperatures, gas emissions, and large hydrothermal eruptions. This is not a typical event. Right after one of the major incidents at New Crater. This morning, Steamboat Geyser, the world's tallest active geyser, erupted with extraordinary intensity. A jet of hot water and steam shot more than 130 meters high and, for the first time, directly into the public zone, forcing an emergency evacuation of visitors from the Norris Geyser Basin. This eruption was not only astonishing for its scale, but also for its timing, coinciding with an earthquake swarm and magma upwelling. This is a signal that underground pressure is building up, said Dr. Navarro. The shouts of park rangers echoed through the air as tourists taking photos and relaxing on the walking trails were quickly ordered to leave. Some visitors slipped on the slippery wooden decks, slick with hot mist, but there were no reports of serious injuries, thanks to the quick response of park rangers and the early warning system. This dramatic eruption was no accident. Just hours earlier, the New Crater area had been rocked by a powerful earthquake, part of a massive earthquake swarm that had recorded more than 3,800 tremors in the past 2 days, with a peak magnitude of 5.3. Scientists now believe that all of these phenomena, the earthquakes, ground deformation, magma upwelling, and geyser eruptions, were part of a single cycle of increasing pressure beneath Yellowstone's surface. The Steamboat eruption was not only spectacular, but also meaningful, said Dr. Ellen Navarro, a geophysicist at the Yellowstone Volcano Observatory. The timing was perfect, just hours after a significant increase in shallow magma pressure in New Crater. This was no coincidence. Navarro explained that hydrothermal systems like Steamboat Geyser are highly sensitive to changes in underground pressure. When pressure builds high enough, the eruptions can change direction, strength, and even become dangerous. What's happening in New Crater, the earthquake swarm, the ground deformation, and the Steamboat Geyser eruption, they're all part of one larger geological narrative. Yellowstone's magmatic system is currently under stress, and the response is clearly visible on the surface. Activity beneath the Earth's crust, though invisible, is now sending loud signals to the world above. For scientists, this is a crucial moment to gather data, strengthen monitoring systems, and update our understanding of one of the world's most complex supervolcanoes. For the public, it's a time to remain calm but vigilant, because Yellowstone has proven, once again, that it's not asleep.